Among the reactions of haloalkanes, substitution reaction and elimination reactions are the major. In the elimination reaction, it is the elimination of HX molecule. X stands for halogen atom. This HX is called as hydrogen halide. This molecule is eliminated from the molecule of haloalkane. It is called as dehydrohalogenation. D stands for elimination or removal of this molecule. Now the structure, look at the structure of haloalkane. There are two adjacent carbon atoms. Here, the carbon to which halogen is bonded is called as alpha carbon, and the adjacent carbon to which hydrogen is bonded is called as beta carbon. These chemical bonds, and one chemical bond between them. The remaining two chemical bonds bonded to other groups like hydrogen or organic, that is hydrocarbon group, which may be aliphatic or aromatic, or it may be any inorganic group like this, these groups. And the groups may be small or big, because variety of haloalkanes we have. In this elimination, this part breaks away. This part of the molecule breaks away, resulting in deficient of one chemical bond on this carbon and deficient of one chemical bond on this carbon. This will make up by forming one more chemical bond between these two carbons, that is pi bond. As these bonds breaks away, new bond formation. It is called as alkene formation. Sigma bond and pi bond. So dehydrohalogenation results alkene formation. This reaction is exactly reverse of addition of HX on alkene. In this elimination reaction, that is alkene formation, is the elimination of simple molecule hydrogen halide. That is X is halogen atom. We find three different mechanisms, three different steps of reactions, but the reaction remains same. That is, product remains same. The product formation is alkene only. Sometimes alkenes of different isomers, alkene formation only. But mechanisms are different. The reason for different mechanism is, look at this haloalkane. It depends on what is what I said in organic chemistry. It is selectivity and reactivity. The mechanism depends on selectivity and reactivity. It is selectivity and reactivity of the reactants. There are two reactant molecules, haloalkane molecule and base. Here, the two reactant molecules, haloalkane and base. Selectivity and selectivity depends on the structure of the molecule. The selection for the mechanism depends on what groups are bonded. Remember, what groups are bonded to these carbon atoms. And the reactivity depends on the chemical reactivity, that is reactivity of these chemical bonds, this H and H. Not only on this reactant molecule, it also depends on the molecule of base, whether base is reactive or what kind of molecular structure the base has. That is selection and reactivity. This all depends on the molecular structure and reactivity of the reactant molecules. So now let us understand. See what is look into the different mechanisms involved. One is E1, that is dealt with in detail the previous class. E1 mechanism, and another is E1 CB mechanism. One more mechanism is E2 mechanism. What are the steps involved in this? Just in brief, let us go through it. Here the molecule is haloalkane. So it is alpha carbon, beta carbon. This bond is X, this bond is H. In this E1, first X is eliminated as X minus, first step. Followed by second step, H is removed as H plus. First is X is removed as X minus and H is removed as H plus. But in this mechanism, first H is removed as H plus, then X is removed as X minus, two steps. And in E2 mechanism, it is simultaneous removal of HX, simultaneous breaking of chemical bond in one step, no two steps. That is called as E2. Details of this mechanism. Look at this. This chemical bond breaks, unsymmetric breaking. Both electrons are taken away by this as X minus. Therefore, this carbon is deficient of an electron because positive charge. It is called as carbocation formation. This reaction is slow reaction. Carbocation formation. This intermediate, once this intermediate form, that is molecule intermediate state is formed, this is carbocation. This carbocation has a tendency of losing the hydrogen. This carbocation makes this hydrogen more acidic. Adjacent carbon. More acidic means tendency of that is ejecting this H as H plus. Adjacent carbon from the carbon. Because plus, it has a tendency of losing plus from this molecule in the form of H plus. Because molecule. That is, this chemical bond breaks and both electrons remain over here forming double bond. This H is removed as H plus, nullifies the charge, alkane formation. Among these two steps, this step is slow reaction, this step is fast reaction. For this requires weak base, action of weak base on this. Weak base acting on this to remove H plus. And also very important, requires heat, because even in all mechanisms, in all these reactions, the reaction, that is consume heat, molecules consume heat. Molecules consume heat, endothermic in nature. All reactions are endothermic in reactions. All substitution reactions are exothermic in reactions, spontaneous at low temperature. These reactions are spontaneous at high temperature, endothermic. Because those molecules require, that is, consume molecule heat to make that reaction. This reaction is fast reaction, of course. This is the mechanism, two steps mechanism. And in this mechanism, first removal of H from this. Therefore, this molecule or the nature of this molecule, like that, this hydrogen should be in acidic state, at least to some extent. Acidic means can able to break this chemical bond, remove as H plus. For this, the nature depends on the carbon as well as it requires very strong base to act on this hydrogen. So here it requires weak base like this, water, methanol and ethanol. They are weak bases. Requires strong base, very strong base like this. Sodamide in aniline, there is methane. Sorry, sodamide in ammonia, liquor ammonia. That is alkoxide in alcohol, corresponding alcohol. Alkoxide in corresponding alcohol. That is sodium ethoxide in methanol. Sodium ethoxide in ethanol. And it is tertiary butyl alcohol. tertiary butyl oxide, sodium oxide in butanol, tertiary butanol. Here CH3, 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 C, CH3, 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 C, butanol, tertiary butanoxide, sodium. These are also very strong. These are very strong bases required for this. To remove this H has H plus, strong base is required. Action of strong base is required. And the carbon, the nature of carbon here, the substituent should have that kind of the carbon bodies that make this hydrogen as more acidic as well. So H is removed and heat is also must. Without it, this chemical bond doesn't break. And this reaction is first reaction. When H is removed as H plus, this unsymmetric breaking. Both the electrons of the bond remains on this carbon. This H is removed as H plus. Therefore, the carbon forming is carbon anion. Intermediate formation. Look the difference here: carbocation formation, carboanion formation. This compound or intermediate is called as, that is conjugate base. What is conjugate base definition? When a molecule losing hydrogen ion, that is acidic. When a molecule losing hydrogen ion, the resultant is called as, what is that? Base called as conjugate base. Here, this is what is very weak acid like this. This becomes strong base. That is conjugate base. That is an intermediate formation. Require all this strong base, heat, and the nature of carbon where the substituent present to act this hydrogen as an acidic hydrogen. This intermediate formation, what is that? Anion is there, as a tendency of remove or eliminate the adjacent group as X minus, because minus is there. This minus, that is bond pair electrons form a chemical bond, that is pi bond formation. This chemical bond breaks away as X minus. Both the electrons are taken away. These electrons are shared for this chemical bond formation. Slow reaction. Once it is formed, this will follow. This is fast, this is slow. Difference here look at. Here first step is slow, second is fast. First is fast, second is slow. This is the mechanism. And the mechanism for E2 reaction is, it is not two steps, only one step of reaction. That is, of course, this reactant here, the major difference between this and these two. These two reactions are ionic reactions. It is ion formation. Ion is removed, ionic formation. Again, ion is removed, neutral molecule formation. So, ion is removed, ion formation. Ion is removed, neutral molecule. Ionic reactions. But this is not ionic reactions. It's a covalent reaction, covalent bond. So, in this case, what is that? Single step reaction. Base is a must. What kind of base? Strong base, very important. And strong base, what kind of strong base? Alcoholic AOH or alcoholic NaOH or alcohol and alkoxide. Very important. The hydroxide, what is that? The base should be a very strong negatively charged base like this, containing oxygen. OH minus or O minus. It is derived from the KOH or NaOH. It is derived from the, what is the alkoxide like this mixture. And these ions actually, what is that, potentially act on this hydrogen in absence of water, non-aqueous. Either alcoholic or aprotic. Very important. Because this action is very important. This is not ionic, this is covalent, and the base act on this like this. This requires only potential strength. If water is present, only alcoholic or aprotic solvent is very important. If water is present, this water will solvate this ion. that is ionic charge, solve this ion, and that is prevent the potentiality of this ion to act on this. That is why it requires alcoholic or aprotic solvent with this ion fully potential to act on this hydrogen. Once the base is acting on this, begins to act on this, begins to form a chemical bond between base and hydrogen. Once it happens, that is partial bond formation. Now this consequently what is that requires what is as a consequence, this bond begins to break, and this bond also begins to break. As this bond begins to break, this also begins to break with this bond formation, and simultaneously this new chemical bond begins to form. Here forming, breaking, begins to form, begins to break, begins to break. With this action, very strong base like this, OH with alcohol or aprotic solvent. That is the most important condition for that. So forming intermediate complex, not a step. Of course, intermediate complex is that is called transition state, irreversible with this complex formation, because it should be like this in transpiration. H and X should be in transpiration to make what is that it becomes more stable intermediate complex or transition state. That is why they are in a transposition. Now this complex is decomposed. This bond has become stronger and stronger. So this becomes a solid bond. This becomes Hb, and this is removed as X minus. Later these two mix by Hx and B minus of course. This is alkene formation in one step, is the intermediate or transition state. That is the mechanism, into mechanism. E1 and ECB mechanism. Now what is the reason for this E1? I told you reactivity and selectivity. It is reactivity order. That is tertiary carbon, secondary carbon, primary carbon. That is depends on this carbon. What kind of carbon is this? That is reactivity order. That is favorable. The factor favoring this reaction or mechanism is that is tertiary carbon. Next is secondary carbon. This is this. So tertiary carbon favor this. Among this reactivity. Tertiary carbon and this next. This also tertiary carbon. This carbon or this carbon should be in tertiary state or secondary like this. So these two are reactivity. All of them depends on what is the same order of reactivity. What kind of carbon is this? Tertiary carbon is favorable all this mechanism of course. But second condition is very important. Here it requires weak base like this, protic base or water like this. That is protic is proton categories, polar solvent, protic polar solvent. Like this and this. This is most important. Weak base. But requires strong base but protic solvent. Like alcohol. Very strong base with protic solvent. That is strong base like this. And here strong base, and this also what is that there is strong base with alcoholic or aprotic difference. Very strong base, aprotic solvent or alcoholic very important. This is the one that's important role. So it all depends on what is that base very important. So weak base can favor this. Strong base like this will favor second condition, and a strong base like this, that is alcoholic, this ionic negative charge, favor this mechanism. That is another condition. And most important more condition for selectivity, what is the favoring this mechanism is EDG on the substrate. Electron donating group. This carbon, what is that? Showing the bond. These bonds should be bonded with a group like this. electron donating group CH3 C2H4 like this. We can stabilize the carbocation, that is carbocation, because electron donating, these bond electron can donate to neutralize, that is not just nullify the effect like this to make this more stable. Very important, stable intermediate formation is the one in favoring this reaction. But whereas in this mechanism, exactly reverse case, that is this what is that? Conjugate base formation, minus is there. And the group bonding to this carbon should have electron withdrawing group like this. That is nitro group, carbon and CO group, Cl, cyanide, Cl or phenol or benzene ring like this. So any group connecting to this will favor this mechanism because electron withdrawing group. This is electron rich. The group which can withdraw electron can somehow nullify the effect and make this more stable complex and favor the formation of the complex like this. That is why this also plays important for selection. If these groups are present, this will select this mechanism. If these groups are there, this will select this mechanism. Another, this will not select any kind of this, but only the strong base like this. Because covalent, the reaction is covalent. And covalent all reaction will not favor in the aqueous medium. In aprotic solvent will favor. That is why aprotic or alcoholic medium very important. And one more depends on the group, the reactivity of this. Fast leaving group will favor this. That is presence of this I and Br here. Any I or Br present will favor this mechanism, select this mechanism. And this mechanism is favored, that is X is a poor leaving group because spike is removal of H plus, not X plus. So it is already what is that bonded strongly. The presence of F or Cl will favor this mechanism. Will select this mechanism. Presence of F and Cl will select this mechanism. Selection. And this also better leaving group. That is, here both are leaving now. Better leaving group because if it is better leaving group now, like this. A fast leaving group like Br and Ir. So these two are follow same thing. And I said because all the reactions, that is any reaction, dehydrohalogenation is always take place in a solvent. This is always a medium like protic solvent like this. This is most important. This is polar solvent protic. This is alcoholic medium. Usually you go for alcoholic medium. Protic solvent like this. Of course, water may not be used in this case. Protic solvent. And here aprotic solvent. This is most important. Avoid this. This is more potential to act on this. That is why aprotic solvent are alcoholic, non-aqueous medium. And one more, the kinetics of this reaction. Here the first step is slow reaction, therefore it is a rate determining step. Only one molecule is involved. Therefore rate of reaction depends on the concentration of the halide, not on the concentration of the base, this molecule. Afterwards the base can act. Zero order. With respect to the concentration, zero order. Overall order is 1 plus 0. And it is unimolecular. Step means only one molecule is involved. Unimolecular reaction. Therefore, one stands for unimolecular elimination. Unimolecular elimination. It is unimolecular reaction. But order is 1 here. Look at this reaction. Slow step, it is a rate determining step. But here it is not a reactant, it is an intermediate. Intermediate concentration should not be taken. Always for rate of reaction, the reactant concentration should be taken. But this intermediate formation depends on the concentration of this as a concentration base. Both are important. Therefore, it depends on the concentration of this, concentration of this. Therefore, R equals second order, 1 plus 1. But look at this mechanism step. Only one molecule is involved, that is unimolecular. The molecule is intermediate but conjugate base like this. That is why one stands for unimolecular elimination reaction involving conjugate base. That is why conjugate base, this mechanism. On the basis of this kinetics, we are classifying this as well as this. But on the basis of this, we are classifying as this reaction, what is the step of reaction? It is depends on the concentration of this as well as concentration of this. It is not shown this concentration of this plus now. Depends on this activity of this as well as activity of this. Ratio 4 of 1, ratio 4 of R equals 2. And both molecules are involved in a step. Plus should be written but not written directly over here. This plus this. That is bimolecular reaction. So step of reaction is bimolecular, that is bimolecular elimination, single step, bimolecular elimination, the kinetics. So from the kinetics, these are designated as mechanisms. And from the kinetics again, what is that? In terms of energy propelled diagram, look at this. The step is slow, step is fast. Slow, there are two steps of reaction. From year to year, there is energy propelled diagram. Rise to high energy, then becomes low, there is energy variation during the reaction like this. This height is more because of slow reaction. Slow reaction. Next step is from year to year, that is energy low, and there is energy low, fast reaction. Lower the energy barrier, faster the reaction. Slow step, fast step. But it is reversed. First step is fast reaction. From year to year, this energy barrier, variation energy barrier. Barrier height is less, fast. From this to this is energy barrier. The height is more because slow. Because of energy barrier. The kinetics of this mechanism. Kinetics of this mechanism. But here only one step reaction is only one complex from year to year. But through transition intermediate cooperative complex here. This is E2 mechanism, kinetics of this. And the last point let us stress upon, that is E1 mechanism can compete with SN1 mechanism. That means the reaction becomes even elimination at high temperature. But the same reaction becomes SN1 nuclear substitution becomes at low temperature. Becomes nucleophilic substitution at low temperature. That is why there is a competition between this and this, either this or this. Depends on temperature. Here also. Here these reactions are common. These reactions are very rare reactions. And in this reaction, this is E2 can compete with SN2. It is E2 at higher temperature, SN2 at lower temperature. This is most common reactions. Among this mechanism is very rare. This is common, but most common among them is this. These are the differences between different mechanisms. Differences between different mechanisms, but reaction remains same. This all depends on selectivity and reactivity of the reactant molecules. So with this knowledge, keeping these points in mind, let us write the reactants for different reactants. Same product, but what is the mechanism? Whether here the mechanism is E1 or E1Cg or E2. Let us see that with examples in the next session. With example, let us understand what mechanism the reactions follow depending on the different reactants. Continue.